Section 7.1, Exploring Exponential Models. By the end of today's lesson, students are going to be able to model exponential growth and decay. An exponential function has the form y equals a times b to the x power. If a is greater than 0 and b is greater than 1, this is going to represent exponential growth. If a is greater than 0 and b is greater than 0 but less than 1, so it's a fraction, then this is going to represent exponential decay. To find the y-intercept, it is the point 0, a. Your domain for all exponential functions, the domain is going to be all real numbers. The range is going to be from your asymptote, and then it's going to be y is just greater than whatever your asymptote is. Okay, your asymptote is whatever number is at the end. So for this entire section, your asymptote is y equals 0. Let me show you a brief picture of this as a graph, okay? Exponential functions are curved, and this is going to represent exponential growth because it's growing as you move from left to right. There is an invisible asymptote right here, which is going to keep your graph from ever going through that. I could draw it the other way, and this would represent exponential decay because it's decaying as you go from left to right. And again, still an asymptote right here, which is going to keep your graph from going through that line. Let's find out what the graph of y equals 4 to the x power looks like. So there's three numbers you always want to plug in, and you want to plug in -1, 0, and 1. So if we plug those in for x, that gives me 4 to the negative first power. A negative exponent makes it move to the denominator and become positive. 4 to the 0 power, anything to the 0 power is 1. And then 4 to the first power is 4. So let's graph those 3 points. And your graph looks like this. Okay? So your y-intercept is 0, 1. The asymptote, y equals 0. It's an exponential growth. The domain, your domain, again, all real numbers. The range, y is greater than 0. It's not equal to because it cannot ever touch at that point. Our second example is y equals 2 times 3 to the x power. Again, we want to make a little chart, and we want to plug in -1, 0, and 1. So that's 2 times 3 to the negative first power. So The negative 1 as the exponent makes this 3 1 over 3. And then 2 times 1/3 is 2/3. 2 times 3 to the 0 power makes the 3 to the 0 power a 1, and 2 times 1 is 2. 2 times 3 to the first power, 3 to the first power is 3, 2 times 3 is 6. So let's make a graph of this. So negative 1 2/3, 0 2, 1 6. Okay, still exponential growth, which makes sense because my b was a 3. The y-intercept this time is 0 2. Remember, that makes sense as well because it's whatever a is. The domain again is all real numbers. The range, y is just greater, not equal to, just greater than 0. And your asymptote is y equals 0. Now let's see if we can determine whether it's exponential growth or decay from a given equation. And let's also write down what the y-intercept is going to be. So we have y equals 3 times 4 to the x power. So you have to first determine what a is and what b is, and remember b is always the thing that has the exponent. So b is 4, 4 is greater than 1, so therefore this is going to be exponential growth. Okay, then let's determine what the y-intercept is. Two ways of doing that. You can either plug in 0 for x, or in this case it's whatever a is. So my y-intercept is 0, 3. Example 4, we're given 11 times 0.75 to the x power. Again, b is always what has the exponent. So since b is 0.75, this is exponential decay. The y-intercept is 0a, so it's 0, 11. A way for us to model exponential growth or decay is this formula. So we have a of t equals a times the quantity 1 plus or minus r to the t power. Okay, so a of t is going to represent the amount after so many time periods. Okay, the little a is your initial amount of money. R is going to represent your rate of growth. And T obviously represents time. So the reason I wrote 1 plus or minus r is for these two reasons. It's going to be 1 plus r if you are growing. And then it'll be 1 minus r if you're decaying or if you're losing money. Let's use that equation that we had from the last slide to help us solve this problem. It says, suppose you invest $500 in a savings account that pays 3.5% annual interest. How much will be in the account after 5 years? So I'm going to write down the equation from the other page, a of t equals little a times the quantity 1 plus or minus r to the t power. All right, so first of all, what do we know? We know that we invest $500. So since that's how much money we start with, that is going to go in for a little a. All right, and then it says in a savings account, that pays 3.5%. So this is my rate right here, 3.5%. But I have to change my 3.5% to a decimal. So to change it to a decimal, we have to move the decimal place to the left. So it's going to be 0.035. Now, do savings account pay you money or do they take money away from you? Okay, I hope that you guys know that it gives you money, so therefore it's going to be 1 plus 0.035. And then it says, how much will you have after 5 years? So I plug in 5 for T. And this is going to give me the amount I will have after 5 years. And now we just pick up our calculator and we solve. After 5 years, we have a total of $593. And then since we're talking about money, make sure you round to the right decimal place, and 84 cents.